everyone, welcome to my YouTube channel. My name is Anup Singh. You are watching AeroTech Advance YouTube channel. In today's lecture or in today's video, we are going to discuss the remaining points or remaining topics of chapter number 2, that is Basic Aerodynamics of 2D wing. On the last 3 lecture, basically we are covered all the important and basic geometrical parameters of 2D wing, that is called airfoil. So today we are going to see the remaining points or remaining topics of related to airfoil of aircraft. So let's start this video. So we are going quickly on that slide. Yes. So today we are going to see the aircraft force diagram, that is a flight force diagram. So everyone is already aware about that. There are 4 basic forces are created during the aircraft operation, that is lift, thrust, drag and weight. I don't think so there is a need to explain in detail about this. Everything is created because required during the flight. The lift is everyone is know, because of that we are using the aircraft wing. Weight is because of aircraft weight is pulling in the downward direction because of gravity of the earth. Thrust is produced because of engine of the aircraft, and drag is produced because of profile of the aircraft. So this is a very basic things that everyone is already aware. Here I shown this slide because I find out few of the students don't know what is the force diagram of the across the aircraft. Now you can see in this figure, that is the aircraft forces and moment. There are 3 axes. There will be a longitudinal axis, vertical axis and lateral axis. That is very important. Through the longitudinal axis, aircraft is rolling, doing the rolling moment. With the help of this vertical axis, the aircraft is doing yawing moment, and with the help of lateral axis, the aircraft is doing pitching moment. Understand? So with the help of that 3 axes, the aircraft controlling its stability across all the 3 axes and all 3 moments. Now we are going to talk you about elementary aerodynamics. So in the elementary aerodynamics, which parameter is responsible that affecting the aerodynamic properties of aircraft wing? So the remaining at the previous, if you see on my previous lecture, we have discussed only geometrical parameter, but apart of that also there will be some factors are available that also affecting the aerodynamic properties. So let's see which one. The first one is configuration geometry. So geometry of the aircraft depends how it is. Then angle of attack. The angle of attack is also affecting the aerodynamics property. If angle of attack is very high, so stall condition is going to arise, and at the stall condition, lift coefficient is decreases suddenly. Understand? And drag is increasing suddenly. Vehicle size and model scale is also very important. That is also affect the aerodynamic forces. And the free stream velocity, density of the undisturbed air, Reynolds number and Mach number. This all parameters is important parameters that affecting the aerodynamics property of the aircraft. The next is effect of the lift, that we already discussed, so there is no need to go through it. Yes, boundary layer flow separation, guys. This is very important because you guys are finding these types of topic in fluid mechanics in 3rd semester. The boundary layer flow separation is important to know because what happened, there will be a one very important parameters, that is stall characteristics, or you can say stall condition. Actually stall condition is the unfavorable condition and unacceptable condition that arise because of some reason. What the reason? Reason is that boundary layer flow separation. So at the stall condition, the lift coefficient is decreases suddenly and the coefficient of drag is increasing suddenly. Understand? So that's the reason stall condition is very dangerous condition and very wasteful condition, unfavorable condition. So how it is occur, guys? It's occur because of boundary layer flow separation. The boundary layer flow separation is the phenomena where the fluid particles of the flow is going to stick on the surface of the airfoil. Understand? Let's understand how it is separate, why the boundary layer is separate. So adverse pressure gradient interacting with the velocity profile through the boundary layer. If you see in this case, the first case, the fluid particle having the very low momentum and low velocity at the surface, that is trying to stick. So in second case, the adverse pressure gradient is created, and because of adverse pressure gradient, in third case you can find out the flow reversal take place, means deceleration of the flow is take place. So that is because of flow separation, and that's create a stall condition. So high speed flow near the upper edge of the boundary has enough speed to keep moving through the adverse pressure gradient, and lower speed fluid is exposed the same adverse pressure gradient is stopped and direction of the flow can be reversed. Understand? Because of that reversal flow is take place, and this reversal of the flow direction causes flow to separate. Understand? Flow to separate. And because of flow to separate, obviously I need to avoid these types of condition there. So there are 2 points what I have mentioned to avoid there is a method to avoid the flow separation. We can use the turbulent boundary layer that avoid the low energy momentum fluid particles near the surface of the body, and that help the flow separation will desired as a turbulent boundary layer, because turbulent boundary layer having the fluid particles having more energy, that energize the low energy fluid particles what is sticking on the surface of the airfoil. That's the reason this is a method that is called a boundary layer control method. So in boundary layer control method, you are going to learn how to avoid or delay the flow separation, and only boundary layer flow separation is the factor that causes the stall condition. So guys, this is the last topic what I need to explain you in the chapter number 2, that is basic aerodynamics of the 2D wing, that is airfoil. And guys, today we are completed our chapter number 2 with the help of this lecture number 4. So there are 4 lectures for completing the chapter number 2 I have taken. Otherwise I have take only one lecture to complete this whole chapter, but what happened, the students are not going to see the lengthy video, especially in YouTube. That's the reason I have made this whole chapter video lecture in 4 lecture part. Understand? So guys, if you have any question related to this chapter, basic aerodynamics of 2D wing, that is airfoil, you can ask me in the comment box. Otherwise you can follow my Instagram and ask your question in my message or chat box. So guys, thank you so much for watching my video. Thank you.